Now we are going to look at the loss at issues. What does loss at issue means? Okay, when we are talking about at issue, it means that at the moment or at the time where the policyholders and the insurance company sign the contract, which is at time zero. Loss at time zero. Loss is from the point of view of the insurance company. What we know previously from the previous video, APV of the benefit equals to APV of the premium. This is the expected value of the amount of the insurance company are going to be paying out to the policyholders whenever the policyholders die or whenever the term is matured, for examples endowment or pure endowment. And this one would be the amount that the expected value that the insurance company will be collecting from the policyholders. So this would be a negative, or the paying out for the insurance company. This would be the income for the insurance company. So when we are talking about loss, the notations for loss is L, and 0 means at issue, that means at time 0. This is actually equals to the present value of the benefit minusing the present value of the premium. How much the insurance company has to pay minusing how much that the insurance company is collecting will be equals to the amount of loss incurred for the insurance company. Okay, under the equivalence principles, we say that the expected loss here, it will be APV of the benefit minusing the APV of the premium. This shall be equal to 0, because under the equivalence principle here, it says that APV of the benefit shall be equal to APV of premium. So if it is equal, when you deduct, it shall be equal to 0. Let's look at examples. Okay, let's look at the fully continuous whole life insurance example. Examples for fully continuous whole life insurance. For the fully continuous whole life insurance, the APV of the benefit would be let's start with present value of the benefit. Present value of the benefit would be equal to how much is the benefit, TX. Present value of the premium would be equal to how much of the premium, and then it will be collecting up until the time that the person's died. Okay, so for this case, we can say that loss equals to as VTX minusing pi A bar TX, which is also equals to as VTX minusing pi 1 minus VTX over delta. So for here, we can say that this one we can combine all the VTX and the VTX, so you are going to have S plus pi over delta VTX minusing pi over delta. This is loss from the perspective of the insurance company. What the insurance company is more interested is in the expected loss. They are looking for the expected loss. Usually it shall be greater, or expected loss should be kept minimum, which is usually sometimes they kept it like 5% or 10%, or the probability of the expected loss should be very, very, very minimal. Okay, so whenever you are looking at the expected loss or the probability of loss, expected loss is just simply the expected of all of this. Okay, you are going to get the expected of all of this. For examples here, if you go for the expected loss, here you are going to get expected of this is still this number. Okay, and then expected of VTX would be, it will be easier if I use this one. Yeah, expected of S VTX is to be S A bar X, and then expected of this one, it will be minusing pi times 1 minus A bar X over delta, which is equals to S A bar X minusing pi A bar X. And the variance for this loss would be equals to variance of S plus pi over delta VTX minusing pi over delta, which is variance of constants is here, it will become 0. Variance of this part, it will be S plus pi over delta square V variance of VTX, which is S plus pi over delta square. Variance of VTX is 2 A bar X minus A bar X square. Remember, these kinds of expected and variance using this kind of formula, you can only use under equivalence principle. If it is not under equivalence principle, usually there will be covariance involved, especially for the discrete case. Now, let's look at the probability. What are the probability that the insurance company interested in, which is keeping the probability of loss to the minimum. Okay, so we know that just now loss is equals to S plus pi over delta times with VTX minusing pi over delta. Whenever there is loss, that means that this minus this, it will be greater than 0. Okay, so you are looking at the probability where this of the minus this greater than 0 will be kept to the minimum, the amount of whatever that the insurance company want. So usually when you are looking at this, you are looking at probability of loss greater than 0 would be, for example, equals to 5%. Okay, you are comparing these to the amount of the loss that may incur, the probability that may incur. It is very difficult for the insurance company to keep it very, very low or close to 0. They will have some amount of the probability which is may incur the loss, because if they want to keep it 0 or very, very minimum 0.0001 and so on, that means that the price or the premium for their insurance pay to charge to the customers will not be competitive enough in the market. Okay, so for this case, we can always find from here your Tx, you just rearrange the equations, shall be lesser than negative 1 over delta ln pi over S delta plus pi. You just bring whatever here to this side and then left here Tx. Okay, so whenever that you are looking at probability of loss which is greater than 0, this is also equals to probability of Tx which is lesser than T, where your T now here is this amount, okay, which is also equals to f as in the CDF of 1 over delta ln pi over S delta plus pi. So you are going to cap that this one is greater or lesser than 0. That's it for the introductions of the loss at issue. Thank you.